I like doing one of every test manually because I like making sure you guys know why something does what it does. Once we've done it once manually, we use technology to finish it off for us. So let's do it. Here comes Prevnar. Tests. One prop Z test. If that's even visible on the camera. Oh, it's not bad. It's good. All right. Feed it in. Feed in the stuff. Feed in the stuff. We got a null hypothesis of 135. Of our infants. How many did we give Prevnar to?
Total of 700.
Total 700. How many got appetite loss?
710.
Oh, 710. All good. Thank you, friends. How many got appetite loss?
121.
121. By 17%. That's your 17%. We're going to scroll down here. Just make sure you change your sign. Make sure you change your sign. Make sure you're pointing the same way your research. I'm sorry, guys. You can't see that very well. Okay.
No.
Make sure you're. That's not much better, is it?
It's that one.
Is that a little better?
Yeah.
Focus. There we go. Make sure you point your sign the same way that your research hypothesis is pointed. So it's H1 goes in that secondary line. Why does the TI write it this way? Because they can and we keep buying their machines. I wish they didn't. I wish they used H1 and H0, but they don't. So now last time we did a calculate. What I'd like you guys to do is hit draw this time. This is my favorite way of dealing with this. Because if you do draw, it actually draws the curve for you, shades the p-value, and gives you the test statistic and the p-value's value. Is that fair? Now, we did the calculate screen last time, which was great, and that was fine. Let's make sure we see this. Make sure we see this. Okay, here we go. So now we have 7 and 8's answers. 7 was, what's the test statistic? That was the red question mark up here on the board. What went here? 0 is paired with 0.135. What's paired with 0.17? Well, apparently it looks like 2.76. Slide over this way a little tiny bit. Nope. Zooming the wrong way. Camera's falling apart. Dogs and cats living together. Mass hysteria. There we go. Okay. Slide this over a smidge. Notice how the curve lines up with mine? That was intentional. I like seeing the curve. No, Elizabeth, go ahead. What doesn't line up?
No, I just, now you can't see it.
You can't see it. Oh, shoot, because of the glare. I'm sorry.
Okay.
I'm sorry. Well, look at this one. That's okay, look at this one. Now, I drew this probably too far this way, didn't I? If you see, look at the p-value on that.
Tiny.
It's tiny. Oh, I like that word. It's 0.0026. That's like a 1 in 400 chance. That's like flipping heads on a coin a bunch of times in a row and pretending the coin is fine. No, this is not flipping heads infinitely on a coin and then getting a string of heads in a row and going, oh, that could have just happened by itself. We'll talk about that in a minute. But that's a tiny p-value, isn't it? 0.0026. That's 0.26%. That's 1/4%. That's a 1 in 400 chance. Let that wash over you a little bit. It's a 1 in 400 chance. Tell me what that tells us to believe. What does that tell us to believe? When you get a small p-value, your data essentially landed 2.76 standard deviations out here somewhere, yes? Way out here somewhere. What do you believe? What do you believe about Prevnar?
It's too high of a rate.
It's too high of a rate to believe what? Go, sir, go.
Go that it's usable, or it.
Good, no, you're saying the right thing. You're saying the right thing. Let me give you a little different context, Brian. You're saying exactly the right thing. Do we believe that this appetite loss rate, 13.5%, applies to Prevnar? Do we believe Prevnar has the same appetite loss rate as the competing medication?
No.
I see a couple heads shaking no, shaking no, shaking no. We don't believe it. Why?
It's outside the company.
Because it's too far to the right. It's outside the confidence interval. This appears to be on a bell like that, doesn't it? That's that secondary curve I keep talking about, this type 2 curve. It looks like it's more on a curve like this, doesn't it? It's too hard to believe that Prevnar belongs on this curve. It might, but it's really hard to believe with a 1 in 400 chance. If that was like a 20% chance or a 25% chance or a 48% chance, they'd be like, okay, that's close enough. But it's so hard to believe. Think about it this way, friends. If I gave you a coin and you flip the coin, actually, let me answer that question right now. I can't do the math in my head. What is the natural log of 1 in 400 divided by the natural log of a half? There. If I gave you a coin and you flipped it 9 times in a row right now, and you got 9 heads in a row, how many of you would sit there and be like, whatever, random chance? We got one chuckle, we got a smirk. How many of you, if I gave, you know what, the hell with it, I got coins. Get a coin. Here, get a coin. Hand them around. Pennies. Everyone flip a coin 9 times. Please, hand them back, flip a coin 9 times. Let me know if you get 9 heads in a row.
I already got tails.
Or 9 tails in a row. Either 9 heads or 9 tails in a row. Let's go with that. Flip a coin 9 times. You don't seem convinced. You don't seem convinced. Flip a coin 9 times.
What if we don't right off the bat, can we stop?
If you don't right off the bat, we're going to try it again, maybe.
I've got 3 tails.
3 tails. Keep going. You got 6 more.
Oh, man.
Shit. Keep going. Let me know if you get 9 heads or 9 tails in a row. Technically speaking, that would be 8 if you're doing 8 and 1. That's the infinite monkey theorem, where they get every word except one of Shakespeare's complete works. 2, yes.
No, I got 8 heads.
You got 8 heads and a tail. We're getting a nice distribution. What's the average number of heads and tails supposed to be? 50-50, 4.5 of each on average. So Elizabeth, you got 8 tails and a head, and Brian, you got 8 heads and a tail. I love the symmetry. The symmetry's mind-boggling. What do you guys got? Give me some numbers. What and what? 7 and 2? 7 and 2? 5 and 4? 7 and 2? 7 and 2. You got 3s and 6s?
I stopped every time.
Just-
I could restart.
So, you guys keep going. Oh, you're already trying 9 more? 9 more? Good. But you see what's not happening?
9 in a row.
We're not getting 9 in a row. Will we eventually? Of course we will. But what that probability up here tells us is, it's only going to happen once out of every 400 times. You see? That's what that probability tells us. So if you were to pick up a coin and flip it right now for the first time and get 9 heads in a row, what would you think about the coin?
Rigged.
That it's rigged! Wouldn't that be your first guess? Your first guess wouldn't be, well, likely to happen in a long string of events. No! Because you didn't have a long string of events. You had 9, right? It's different than if I said, go ahead and flip this coin, Brandon, a couple thousand times. And let me know if somewhere in there you got a string of 9. That's a totally different question, isn't it? That's a totally different question. I would almost guarantee that would happen at that point. But what I'm saying is, how likely is it that you walked in here today, flipped this coin 9 times, and got 9 heads? As I'm seeing, pretty unlikely, right? So that means the assumption about the coin being fair is hard to believe. Does that make sense? The assumption about the coin being fair is that point on the curve right here. This average right here in the middle, that's the assumption the coin is fair. We landed too far over here to believe that, didn't we? Does that make sense? Keep these pennies with you. Let's keep coming back to those. I think this is a good way of looking at p-values. Maybe? Maybe. It's the same black card example. It's that again, isn't it? It's the same black card example. So, friends, I have a question for you. Which hypothesis do I now believe?
One.
I believe this one, don't I? I believe this one. You said one, I thought you meant the first one. You mean H1, Elizabeth, HA. We have to believe this one, don't we? Might this be correct? Of course. But it's easier to believe this one, isn't it? And that's the uncertainty measure. That's the uncertainty measure. It's possible this is right. With a 1 in 400 probability. it's more likely this is right. With some unknown problem, we'll come back to that too, that's part of the power project. So, step 9, what is it? Yes. What are we gonna circle? Are we gonna circle appear or does not appear?
Here.
We're gonna circle appears. You circle appears because that means it appears something's changed. Your job is to figure out what. So what does it appear?
Prevnar causes appetite loss.
It appears that Prevnar causes appetite loss. Boom. How much? You can't answer that right now. That requires successive tests. We'll come back into that later in the course. Could you be wrong? Oh. Always. What a good answer. Oh, always. What type of error could you have made? This is definitely a type 1 possibility. You can't make a type 2 error because you said something changed. So you didn't make a negative test result, you made a positive test result. Thank you, Elizabeth. Does that make sense, you guys? Good. Prevnar, check. Fair? Good? Makes sense, hopefully. Get there. Any questions on Prevnar or the format of this test? I got more to do. I want to do more, but I also want to take 5 because now we're 10 minutes over our break time. Any questions you guys have before we break for a moment? I gotta fix my stand too. It's not holding. Here we go.